Hello friends, welcome to my YouTube channel. Friends, today we are going to discuss the shear force and the bending moment diagram in the lecture series that I have covered, in which I have covered up to 50 video lectures on shear force and the bending moment diagram. So this is a new problem here. Now friends, see here. This is the L by 2 and this is L by 2 and this is a simply supported beam and a point loads is acting at the point B in the middle. We have to draw the shear force and the bending moment diagram for this beam. So the first step is the finding out the reaction at the point A and the point C. So suppose reaction at C is in vertically upward direction shown here, and the reaction at the point A is in vertically upward direction shown here. Now friends, using the equation that RA plus RC is equal to the net vertical load acting over this beam, and it is equal to W. So putting it equal to W, this is our first equation, and moment of all the forces about the hinge is 0. So taking moment about the point A, summation of all the moment about the point A is 0. Okay, for that we have to this reaction will contribute toward a moment of magnitude RC, the magnitude this into this length L by 2 is equal to L into L in anti-clockwise direction about this point A. Okay, and anti-clockwise is here treated as positive, and this force will not contribute toward any movement because it is passing through this point A, and this force will contribute toward a movement of minus W into L by 2 acting in anti-clockwise direction about this point A. That is rotation of this beam element AB about the point A because of this force is in clockwise direction, so it is treated as negative. So putting it equal to 0, you will get RC is equal to plus W by 2, and using this equation you can find out RA is coming out to be plus W by 2. Okay, now friends we will calculate the shear force at the point A, B and C on the left side and on the right side. So shear force on the left side of the point A can be found out by constructing a section here on the left side of the point A and looking for the various forces acting on the left side of this section. You can see that there is no force acting on the left side of this section. That's why shear force on the left side of the point A is 0. And now shear force on the right side of the point A, again follow the same procedure. Draw a section on the right side of the point A. Okay, this is the section XX drawn on the right side of the point A, and looking on the left side of this section, you can see that this force is contributing toward a positive shear force of magnitude RA, and RA is equal to how much? W by 2. So it will contribute toward a shear force of W by 2 having positive magnitude using this sign convention. Okay, now friends, shear force on the left side of the point B we want to calculate. For that we have to construct a section on the left side of the point B. This is the section XX. Now looking on the left side of this section, this force is again contributing toward a shear force of magnitude W by 2. Okay, and the sign is positive using this sign convention. Okay, and shear force on the right side of the point B if we want to calculate, then again we have to construct a section on the right side of the point B. Then now looking on the left side of this section, you can see that this force is contributing toward a shear force of magnitude W by 2 positive using this sign convention, and this force is contributing toward a shear force of minus W about this section XX using this sign convention. So it will give us a shear force of minus W by 2 magnitude, and shear force on the left side of the point C if you want to calculate, then again we have to construct a section on the left side of the point C. Okay, this is the section XX, and looking on the left side of this section XX, this force is contributing toward a shear force of magnitude plus W by 2 using this sign convention, and this force is contributing toward a shear force of minus W using this sign convention, and it will again give us minus W by 2. And shear force on the right side of the point B if we want to calculate, then we have to construct a section on the right side of the point B C, and looking on the left side of this section, you can see that the shear force because of this force will be equal to W by 2 positive using this sign convention. Because of this it will be negative because of this sign convention, and because of this it will be positive of magnitude plus W by 2 using this sign convention. Okay, so the RC is plus w by 2. That's why it is coming out to be plus w by 2. So it will give us 0. Also you can look on the left side, right side of the section and follow the same procedure. The same procedure will give the same result. Now we will draw the shear force diagram. So the shear force on the left side of the point A is 0. So marking 0 here. And shear force on the right side of the point A is plus w by 2, and plus lies above this line, plus things all lies above this line. So our reaction on the right side of the point A will be equal to plus w by 2, going upward, plus w by 2 distance, and shear force on the left side of the point B is w by 2, lying in the same level, w by 2, and shear force on the right side of the point B is minus w by 2. So minus things will lie below this line, so minus w by 2 is taken here below the point B, and shear force at the point C on the left side is minus w by 2. So minus w by 2 will lie in same level, and shear force on the right side of the point C is 0. So mark here. So joining first point with the second is joined with the third by a straight line because there is no load acting between point A and B, and third is joined with the fourth point, and fourth is joined with the fifth point with a straight line because there is no load lying between the point B and C, and this is joined with this. So this will give us the shear force diagram. Now we will draw the bending moment diagram. Now friends, we will draw the bending moment diagram. For that we have to find out the bending moment at the point A, B and C. We do not have to find out the bending moment on the left side of the point A and right side of the point A, doing it the same thing for the point B and C, because there is no concentrated moment acting at the point A, B and C. That's why we will directly find out the bending moment at the point A, B and C. So bending moment at the point A, if you want to find out, then we have to follow the same procedure. We have to construct a section here passing through this point A. Okay, now looking on the left side of this section, there is no force acting, no concentrated movement acting. That's why the shear force on the bending moment on the left side on the about this section x-axis is 0. Now bending moment at the point B. So for that we have to construct a section here at the point B. Now looking on the left side of this section, this force is contributing to about a bending moment of magnitude w by 2 plus w by 2 into this distance L by 2. Why? Because why this sign is taken positive? Because using this sign convention, okay, this force is to try to cause this section of the beam to in concavity up direction about this section x-axis. Similar is the condition x here. This is the section x-axis like this, and this force is acting like this over this beam AB and trying to convert this portion AB in concavity up direction. So it will give us WL by 4. Now bending moment at the point C we will calculate. So bending moment at the point C, for calculation of the bending moment at the point C, we have to again draw a section here passing through the point C, and looking on the left side of this section, you can see that this force is contributing toward a bending moment of magnitude plus W by 2 into L using this sign convention, and this force is causing a bending moment of minus W into L by 2. Okay, using this sign convention, okay, it is coming negative, so it will come out to be 0. Now we will draw the bending moment diagram. Now see, the bending moment at the point A is 0, so marking across here. Bending moment at the point B is WL by 4, so WL by 4 will lie somewhere here above this point B, this WL by 4, okay, and the bending moment at the point C is coming again going to 0. Now we will join first point with the second point with a inclined line, because the shear force diagram is a straight horizontal line between the point A and B, and we will join the second point with the third point with the inclined line because the shear force diagram is a horizontal line between the point B and C. So this is our bending moment diagram. So this was all for today's topic, friend. If you like my video, you can subscribe my channel and also press the bell icon for the notification of the upcoming videos. Thank you friends for watching the video.